All right, welcome to CS61A, discussion number 7, question 3. We're going to do a quick walkthrough of this problem called bear. So this problem tells us to implement the sleepy bear and winking bear classes so that their print method matches the doc test. So let's take a quick look on the classes that were provided and then how we can write the sleepy bear and the winking bear classes. So first we see that the eye class actually tells us what an eye is for this bear. And it also tells us that there's two different types of eyes that we can have. Either the eye is going to be closed, in which it's going to be looking like a dash when it's printed or drawn. And we have an open eye, which is just an eye that isn't closed, and it's going to look like the number 0 when it's open or when it's drawn. Okay, so then we have this bear class, and you can see that for this bear class, when it's print, it's going to have kind of two ears, which are going to be looking like question marks. It's going to have a nose and a mouth, in this case, which is just like a little O. And then it's going to have two open eyes. So in this case, its left eye and right eye are both open, so they're both going to be drawn as zeros. So we want to draw the sleepy bear class. And in this case, the bear is going to look like a normal bear, except its eyes are going to be enclosed instead of open. So let's move over to VS Code over here and see how we might be able to write that. So in this case, we can see that the sleepy bear class is actually inheriting the bear class, which means that we don't need to write our init method or our print method a second time. Remember, we're trying to save code. We're not trying to overwrite or write too much, I guess, in this case. So since the sleepy bear class overrides or is inherited by the bear class, we don't need to write this print statement or this init method again. However, I think we do need to write this next I statement a second time, because in this case, in the bear class, we're creating an I class. And in this case, the I class does not have any parameters set to it. And if we go to the I class, we can see that without any parameters set to it, the closed variable is going to be defaulted to false, which means that our eyes are going to be open on default. So we want to make sure that our eyes are closed for the sleepy bear class. So one way we might be able to do that is to recreate this next I function with self as well. And rather than returning an I without any parameters, we just want to set I here, sorry, not to false, but to true, right? Since our eyes are now going to be closed, we're going to set close to true so that when they're printed, they show a hyphen rather than a circle. All right, and I think that's all we'll have to do for the sleepy bear class. Now let's look at the winking bear class. So the winking bear class tells us that we want to create a bear where one eye is going to be winking and the other eye is going to be open. So in this case, the bear's left eye, I guess from our perspective, is going to be closed, and the bear's right eye is going to be open. Another way that we can think about this is we're actually going to be alternating between drawing a closed eye and drawing an open eye. So we can imagine if we printed this multiple times or we created multiple winking bears, we could have one eye be closed and then one eye be open, and then the next bear is also going to have a closed eye and then an open eye. So we can think about creating this winking bear as alternating between drawing a closed eye and drawing an open eye. So let's think about how we might be able to do that. So, like the sleepy bear, we know that the winky bear is going to be inheriting from this bear class, which means that we can actually call the bear's class initialization method to already have our nose and mouth initialized. So the way we do that is simply by saying super and then parentheses dot init, just like this. And the init method for our bear class doesn't take any other parameters other than self, so we don't need to put anything here. But it's useful to have this init method because we can also create a counter. So why might we need a counter? If we set this counter to 0, what's useful is we know that the counter can go from even to odd, as we add 1 to it. So that's another way of alternating, right? So if we check whether our counter is even or odd every time we create an I, we can alternate between creating an I that is closed and creating an I that is open. So let's see how we might do that. So in this case, if our counter is an even number, then we would want to return a closed eye. And that's because our first case is going to be a closed I. So for thinking about setting our counter to 0, the first case should be closed. So that's going to be just like what we did in the sleeping bear, just setting this to true. Now, otherwise, that means our counter is going to be odd. We want to return an I that is open. So in that case, we can just return I as we would usually. Now, in both cases, we want to make sure that we're incrementing our counter so that the next time we call next I, our counter is the opposite parity. So rather than being even, it's now odd and vice versa. So the way that we can do that is simply by going inside each of these statements and doing self.counter plus equals 1. And we can also do that in a else statement like this, like that. So now every time we call next I and we check if it's even or odd, we then add 1 to the counter and return the I so that the next time we call next I, we can now return the opposite. All right, hopefully that was helpful and have a good time with your discussion.